Hey, welcome to The Explainer. Today we're diving into a technology that honestly shapes the world around us in ways you probably don't even think about. We're talking about CNC milling. So let me ask you this. How in the world do you carve metal with code? I mean, how do you take a solid chunk of metal and turn it into something super complex and precise using just a computer program? It sounds like something straight out of sci-fi, right? But believe me, it's happening right now in workshops everywhere. Okay, so at its heart, the basic idea is called milling. And the best way to think about it? It's like sculpting. Seriously, you start with a big, solid block. That's your piece of marble. And then a spinning tool comes in and just carves away everything you don't need. It's a subtractive process, revealing the final shape that was hiding inside all along. Now, what if you could give that sculptor a computer for a brain and a robotic arm that's like perfectly precise? Well, that's when you get CNC milling. The CNC part stands for Computer Numerical Control. Basically, it's sculpting that's automated, unbelievably exact, and yeah, incredibly powerful. So this idea of sculpting with code is really the core of it all. We've got the basic concept down. So now, let's get into the good stuff. How does that digital code actually become a physical creation? Let's follow the journey from a file on a computer all the way to a finished, tangible object. All right, the whole process really boils down to four main steps. First up, you've got setup. This is where an operator clamps the material down tight and loads up the computer program. Next is tooling, and this is super important. It's all about choosing the absolute perfect cutting tool for the job. Then, of course, comes the action, the cutting. The machine just follows the code, line by line. And finally, you have inspection. You got to make sure the finished part is exactly right down to the tiniest detail. You know, you'll often hear people talk about milling and turning in the same breath. They're related, but the difference is actually really simple and really important. With milling, the tool is what spins, while the part you're cutting stays still. Think complex shapes like an engine block. With turning, it's the complete opposite. The part spins really fast, and the tool just stays in one place to cut it. This is perfect for anything round, like a metal shaft or a pin. And the machines themselves? They come in a couple of main flavors too. You've got your vertical mills, where the spinning tool or the spindle points straight down. These are awesome for really detailed work, for prototypes where you need to see exactly what's happening. Then you have horizontal mills. The spindle is on its side, and these things are absolute workhorses. They're built for heavy, powerful cuts and just churning out tons of parts, like you'd see on a car assembly line. But here's where it gets really cool. The axes of movement. A basic three-axis machine is pretty straightforward. It moves left and right, forward and back, and up and down. Think X, Y, and Z. Great for simpler shapes. But then you add a fourth axis, which lets the machine rotate the part. Suddenly, you can work on multiple sides without having to stop and reset everything. And a five-axis machine? Whoa! It can move the tool and the part at the same time in all sorts of crazy ways. This is how you create those incredibly complex, smooth curves you see on something like a jet engine turbine blade. Okay, so this technology is obviously amazing, but what's the catch? That brings us to our next section, the power and the price. So let's talk about the big wins. There are four huge ones. First off, precision. We're talking mind-bogglingly accurate parts. Then you've got versatility. These machines can chew through more than 50 different materials: aluminum, super hard titanium, plastics, you name it. Third is efficiency. Because it's all automated, one single operator can keep an eye on several machines at once. And maybe the most important of all, repeatability. This is the magic of making thousands or even millions of parts that are all absolutely perfectly identical. And when I say precision, what does that actually mean? It means this: an accuracy of plus or minus 0.01 millimeters. I mean, to put that in perspective for you, a single human hair is about 7 times thicker than that. It's an insane level of detail. And that's the kind of tolerance these machines hit every single time. It's why they are absolutely essential for industries like aerospace or for making medical implants. But it's not all easy. There are definitely some hurdles. For one, the initial cost is steep. These machines and their software are not cheap. And while they can cut hard materials, that can wear down the cutting tools really fast. Also, because you're always removing material, some really tricky internal shapes can be tough or even impossible to make. And finally, you have to baby these machines. They need constant, rigorous maintenance to make sure they stay perfectly calibrated. So, keeping all that in mind, the power, the price, the whole deal, let's bring it all back home in our final section. The world built by CNC. Where do you actually see this stuff in your day-to-day life? Honestly, it's pretty much everywhere. In aerospace, it's busy making critical turbine parts that have to survive insane forces. For cars, it's carving out entire engine blocks with flawless precision. In medicine, it's creating custom implants designed to fit a specific person's body perfectly. And yeah, in electronics, it's what mills the solid metal casing for the phone that might be in your hand right now. And that idea of repeatability, that's really the secret sauce of modern manufacturing. This quote here says it all. It's not just about making a perfect part once, it's about making it perfect every time. When every part is an exact clone of the last, you slash waste from mistakes, and that, of course, saves a ton of money when you're making thousands of them. So, what's the bottom line? CNC milling isn't just some far-off, abstract thing that happens in a factory. It is a fundamental building block of our world. The precision, the strength, the sheer complexity it allows for, it's literally built into the technology we all use every single day. So I'll leave you with this final thought. The next time you pick up your phone and you feel that cool, solid, smooth metal case, I wonder, will you see the sculpture that's hiding inside? Will you think about the simple block of aluminum it started as and the incredible coded dance of a spinning tool that brought it to life? Thanks for joining this explainer.